Hello friends, good morning. It's me Pradeep Yadav and my classmate is Rishi Kashyap. Our project is dynamic resource allocation using virtual machine for cloud computing. Abstract. Cloud computing allows business customers to scale up and scale down their resources used based on their needs. Many of the data gains in the cloud models come from the resources multiplexing through virtualization technology. In this paper, we present a system that uses virtualization technology to allocate data center resources dynamically based on the application demands and support green computing by optimizing the number of the servers in use. Here also we will use the concept of skewness to measure the unevenness in the multidimensional resources utilization of server. By minimizing skewness, you can combine different types of workload nicely and improve the overall utilization of server resources. We develop a set of heuristics that prevent overload in the system effectively while saving energy used. Trace-driven simulation and experiment results that our algorithm achieve a good performance. Existing system. Virtual machine monitors like Chain provide some mechanisms for mapping virtual machines to physical resources. This mapping is largely hidden from the cloud users. Users with Amazon EC2 service, for example, we don't know where our virtual machines run. It is up to the cloud provider to make sure the underlying physical machines have sufficient resources to meet their needs. Virtual machines like mitigation technology make it possible to change the mapping between the virtual machine and physical machine while applications are running. The capacity of physical machine can also be heterogeneous because multiple generations of hardware coexist in a data center. Now, proposed system. In this paper, we will present the design and implementation of the automated resource management system that achieve a good balance between the two goals. What are the two goals? First goal is the overload avoidance and second one is the green computing. Now, overload avoidance. The capacity of physical machines should be sufficient to satisfy the resources need of all the virtual machines running on it. Otherwise, the physical machine is overloaded and can lead to degraded performance of its virtual machine. Now, green computing. The number of physical machines should be minimized as long as it can still satisfy the need of our virtual machines. Idle physical machines can be turned off off to save the energies. Now, the main advantage of this proposed system is we develop a resource allocation system that can overload in the system effectively while minimizing the number of servers used. We introduce the concept of skewness. Objective. The main goal of this project is used for virtualization technology to allocate the resources dynamically. Now, here we are using some modules. These modules are as follows. First one is the cloud computing modules. Second one is the resource management modules. Third one is the virtualization modules, and fourth one is the green computing modules. Now, this is the description about the models. First one is the cloud computing models. Cloud computing refers to the application and services offered over the internet. These services are offered from data center all over the world, which collectively as referred as the cloud. Cloud computing is the movement away from the application needing to install on an individual computer towards the application being hosted online. Resource management modules. Dynamic resource management has become an effective area of research in the cloud computing paradigm. Cost of the resources varies significantly depends on the configuration for using them. Hence, if efficient management of resources is of prime interest of the both cloud providers and cloud users, the success of any cloud management software critically depends on the flexibility, scale, and efficiency, which it can utilize the underlying hardware resources while providing necessary performance isolation. And virtualization models. Virtualization modulus in computing is the creation of virtual rather than actual version of something such as the hardware platform, operating system, and storage device or network resources. Now, green computing. Green computing modules many effects have been made to curtail energy consumptions. Hardware-based approaches include novel thermal designs to lower cooling power or adapting power proportional and low power hardwares. Dynamic voltage and frequency scaling to adjust CPU power according to its load to in data center. Now this is our system architecture. It's divided into mainly three parts. First one is the cloud users, second one is the cloud service provider, and third one is the physical machines. Here n number of physical machines are available, such as physical machine number 1, physical machine 2, physical number 3, and so many number of physical machines available. Now,
data flow diagram. The DFD is also called as bubble chart. It is a simple graphical formalizations that can be used to represent a system in terms of the input data to the system. Various processing carried out on this data, and the output data is generated by the system. And this flow chart is for admin. The admin will log in, and if it will check the username and password will be checked. If it is correct, then he will redirect it to view server status, view website list, add a site, enable site to host, resource allocation status. And this is the DFD diagram for cloud users. When cloud user will log in, it will be verified. If it is correct, then he will redirect it to domain text, domain registrations, choose SLA plan, view cloud user detail, view domain detail, view site status, view site hosting. Use case diagram. It is a type of behavioral diagram defined by and created from a use case analysis. Its purpose is to present a graphical overview of the functionality provided by a system in terms of actors, their goals, and any dependencies between those use cases. The main purpose of a use case diagram is to show what system functions are performed for which actor. Roles of the actors in the system can be depicted. And this diagram is for use case diagram for service provider. After login up by the service provider, he can view the server status, he can view web list, add a site, and enable site to host. The requested site will be hosted by the service provider. And this is a use case diagram for cloud users. Cloud user login can perform domain search, he can see user details, he can view his domain details, he can view his site status, he can create his sites, and these are screenshots. And home page, this is the home page. We have two login, one is cloud user login and another is cloud service provider. This is cloud user registrations. If the user is new, he will be asked for registrations. After registrations, he can log in. He will have to provide the email ID and password. After login, he will be redirected to his home page. That is where he can register his domain and view cloud user details and view his domain details, and he can create his sites, and he also can check his site status. And this is cloud user, a cloud service provider login page. After login, the CSP will be redirected to his home page, where he will be welcome for hosting sites. He can see whether cloud users send some request for hosting sites or not, and it will shown as by processing, where he can add the requested site to the particular websites of to the particular server. Here the www.info is hosted to server B, and this is the graph bar chart of the servers showing the resource allocations. Here the server A is utilized up to 60 kb and server B is also utilized up to 60 kb and server C is shown up to
now we are going to show our project demonstrations. I will go and restart Apache Tomcat and M server. Apache Tomcat. I restart. I am using web server for MySQL database. After restarting web server and Apache Tomcat, I will open Apache Tomcat. Localhost is 81. Manager apps. This is our home page. We have two login, cloud user login and cloud service provider login. I will go to cloud user login. If the user is new, you have to register. Previously registered, so ID is 8 for me. My registered successfully. After registered, I will go and log in. My email was dravid@gmail.com, password dravid. After login, I have to register my domain. So, for example, I will register funzone.com. If it is already registered, then it will show not available. If it is not registered before, that's why I was asked for registration, domain registrations. Now I have to select for SLA plans. 3 months, 6 months and 1 year are available, are given by the service provider. So I have chosen for 6 months, and I will opt memory for 30 KB. Company name I will give as Dravid. Street address Awadi, city After this, I will ask for payment. 5,000 hosting plan and 7,000 and 9,000 are available. I will go for 5,000. Payment type Visa, Mastercard and American Express are available. I will go for Visa. Card number 123. After payment, successfully registered my domain. So after payment, I can check my details, view domain details. This is my details, my email ID, my domain name, my hosting plan, my memory type, company name. I can create site. For that I have to go. I already created a site, find zone. I'll choose Flipkart. After this, user logins work is over. Now service provider, he will check whether some request came or not. If CSP is new, he can create login. If it's already registered, then he can directly go for login. Suppose I am new CSP, so I'll create mine. Zone. So account is created. Now log in. After successful login, I will be redirected to this page where I can see the server process. Server B is allocated 20 KB. Server B is allocated 20 KB, 20 KB, 20 KB for jabang.com, for Yadav. Server C for real estate, server A is allocated 10 KB, and for eBay 20 KB. And now I have opted for funzone.com, not yet allocated that, so it is on processing. I have to go and add the site to the particular server. For that, I will go cloud sites. I will add the sites funzone.com. Suppose I will add to server A, and I will enable it, and it will show site hosted successfully. Now I can see bar server A is utilized up to 100 KB, but server B is also utilized up to 100 KB. Server C is also utilized up to 100, around 150 25 KB. Service provider has only this much works. Now cloud user can log in and check whether his site is hosted or not. Sorry. Allocated. funzone.com is allocated. The hosted site. This is the site hosted by